I'm answering the question. I see on your resume that you took Coursera's UCSD Java specialization. Could you tell us how that advanced you as a software developer and what kinds of projects and work you did there? Sure. Before I took the UCSD course, I had spent several years learning how to use Ruby on Rails. A lot of that was merely learning enough about how the Rails API worked, how to manipulate the black box that is Rails, and how the Ruby language worked to be able to do some basic database-driven web development. Stuff like integrating plugins to do user authentication, setting up AJAX-driven front-end pages, effectively modeling relationships between data objects, and really learning to test it to ensure it was actually working. Learning testing was probably the last piece of that puzzle because it really challenged me to understand the division of labor in a model view controller setup. But still, I didn't really feel like I was doing real programming. I was just playing around with the framework. The UCSD course is very focused on data structures and algorithm development with those data structures. The first of the three courses was focused on the basics of how Java works, with details about class inheritance, abstract classes, and details about memory models. For the final project, we were working with openflights.org flight data and displaying it in a processing.org front-end GUI that made use of a map API that pulled in Google Maps. And we had to extend the functionality of this in some way. So my contribution to this was to add a set of airline buttons that would display the top 10 airlines with most flights according to the flight data. And you click on it and then get the flights for that to be drawn, airport to airport on the map. To get that to work, I imported another set of data from openflights.org about the airlines and had to cross-reference it with the flights with which airline they were tagged with. To do that, I created an airline class that contained which code it had, and also had a number of how many airlines, how many flights it had attached to it. The airlines were then displayed through airline buttons, which was a display class, which had the actual coordinates for each airline button, and they were arrayed out according to how much space there was, and they were laid out in a sort of a patterned way, and they could be continuously redrawn on the screen as the pages were updated. And you clicked on one of those, the on mouse click method would catch it and then redraw the screen only with that airline's flights. And of course you could also hit another button to clear it so that you could put all the flights back up again. So that was a great experience in learning the basics of how to use Java, especially with some of the intermediate kind of features of class inheritance and abstract modeling. The second course was more about data structures, and we went through a variety of them. We were basically working with a back end for a word processing application. So we built methods for things like spell checking, random text generation using a Markov process, and word completion. I think my favorite was the word completion generator. We were using a tree data structure, that's TRIE, which is got a little more information than just a regular tree structure. And the word completer would basically walk down the tree based upon which letters of a word it already had been given and offer back all the potential things further down that tree that would be potential completed words. In the final course, we were all focused on the graph data structure, and looking at road and intersection data from Google Maps. And so we implemented several different search algorithms for route finding, including breadth-first search, Dijkstra's algorithm, and A-star search. And then we had to extend it to do something more interesting about how to handle the endpoints and the searching. And what I thought was interesting was trying to get the or the graph to remember routes that had already been tried, and so that it could make use of the already existing data. The best way I found to implement this was to store the uh, possible routes that had already been used, that had someone had already actually, the program had already spit this out as an answer for somebody who had searched, and add that to a list on each endpoint. And so when that endpoint was called for again, maybe with a different starting point, it would go and basically look at the most popular route that it had for that endpoint and trace it back through the steps, looking to see if each part of the route got closer to the new starting point. And if it found some points in between, it would use that road segment and then build the rest with one of the other search tools to get to that midpoint. And basically, as each route completed, it would go through and it would go try to re-add that route into the endpoints list of routes, matching up different sets, which was a very expensive operation because it's looking at each piece of the completed route and looking at each thing in the list to see if it matches up. So I imagine if this was going to be used, it would be kind of a long-running back-end process, and the front-end process would be merely using at runtime in terms of if you say you were using a web interface, you would just use the recommendations part of it, and then the other part would run on some server that maybe didn't necessarily have to be so responsive, but you wouldn't want to put all that sort of route matching, going through and checking all these pieces of all these potential endpoints on a live server. So I think I've really improved my knowledge of the importance of algorithms and some particular data structures and tools that could be used to make a web-based program, including on Ruby on Rails, viable. And of course, I still have a lot more to learn, but I really appreciate the experience with UCSD and the quality of instruction.